In the previous episode, we examined how the polar wander and changes in the prehistoric climate could be explained by an expanding Earth. A question you may well ask is that if the Earth is expanding, then surely all other planets should be expanding as well. Over the next few episodes, I want to examine what evidence there is for this. We will start by examining some of the most obvious targets, starting with Ganymede and Europa by examining some of Jupiter's satellites. Neil Adams has produced a video showing how Ganymede was expanded, so I wanted to explore this for myself, but I think it makes more sense for us to start by examining Europa, which is considered to be more active than Ganymede. Europa is the smallest of the 4 Galilean moons orbiting Jupiter. It is slightly smaller than our own moon, and it is thought to be composed of silicate rock and then a water-ice crust. It does actually have a very thin atmosphere composed of primarily oxygen. The surface is covered in a series of streaks and cracks, but has relatively few craters, and this probably indicates that the surface is relatively speaking quite young. Europa has the smoothest surface of any known solid object in the solar system, and this has led to the hypothesis that a water ocean exists beneath its surface. The surface is also still active, and they have detected water vapor plumes coming from the surface. There is currently no full scientific consensus among the sometimes contradictory explanations for the surface features of Europa. The most striking features are the series of dark streaks crisscrossing the entire globe. It is relatively easy to show that these cracks line up with others on the other side, showing that parts of the crust have moved relative to the other side. We can sort of divide this image up into 3 sections, sort of divided by these larger flow or movement areas. So let's focus on the top one first and see if we can bring it down to the bottom one and see if things start to align. We can see quite a nice alignment with some of the larger cracks on the surface. It's not perfect, but then there is that movement section that I haven't moved as well. But this triangle here seems to align really nicely, and these lines from one side to the other also align very nicely. Again, there are smaller features that also seem to line up that may not be noticeable on the original image. So let's move the bottom one and see if we can achieve the same sort of result. Again, the large ones, the large channels seem to line up very easily. And again, we're also starting to see some detail in the smaller ones, like here and here. They seem to align up very nicely. Okay, so that's quite a nice sort of fit, but again, you could argue that that's just the movement that they describe anyway. But if you look at this piece here, you can pretty well see that this is sort of a fractured circular pattern that also has that funny sort of eye shape. And oddly enough, there is this structure here which has 2 lobes missing out of it, and I would suggest that this has moved away from it. But let's see if we can join these pieces together first. So let's start with the centerpiece and just align that. Relatively easy to do, and you can see those darker grey lines line up very nicely. Slight rotation, I think, to get it to align, but you can see there's a continuation of some of the lines from one side to the other. Okay, let's do the other end as well. Now this has moved significantly further. We can see the bottom lines up quite nicely, but there's quite a gap at the top. So let's see if we can rotate it and move it into place. Yeah, I think that's quite a nice little fit. It's a bit easier if we remove the background. Yeah, we can see a very good alignment of those lines on the outside and then the lighter coloured lines on the inside as well. And again, a strange pattern above where the eye is. There's a sort of a lighter coloured version of that. But let's see if we can rotate this into this space here, because I wonder if that's an upwelling which has moved away and left its mark on the original piece and then sort of torn what was underneath. And we can see there are lines that do seem to continue from one side to the other. So let's just rotate this and see where we end up. So we can start to see some of those lighter coloured lines that I pointed out do seem to align very, very nicely. We get nice alignment on some of the outer edges as well, where the lines just simply continue from what was there to the rotated image as well. In fact, many of the features seem to align quite nicely, and when we put it there, well, hey presto, that circle, that eye, sits over that other darker patch. And we get nice alignment here, these structures that go across. There's really nice alignment down there. The main consensus is that these were produced by a series of eruptions of warm ice as the crust spread open to expose warmer layers beneath. And this is thought to be similar to the way that our mid-ocean ridges spread. This would then cause the crust to move away. When we examine some of the examples of the larger and newer cracks, we can see that the motion appears to happen in at least two directions in many cases. And this could be explained by a similar crack further away pushing the sheet downwards as well as across. This would, however, mean that these plates must be subducted on the opposite side. Here we would expect to see features simply disappearing with no counterpart on the opposite side. And this should also cause material to build up in these areas. Now the latter are not really visible at all on the surface. We also see very few examples of features simply disappearing. Most of the time we see the cracks continue on all sides. In this example we can see two areas of cracked expansion. If this was due to subduction, then you would not expect the top and the bottom to line up as perfectly as they do. One end should be out of alignment due to the fact that some of it would have been subducted. And yet we do not see this, once more suggesting that each of these cracks is caused by an expansion process. We can also find examples of large chunks of crust that seem to have been broken up and have been moved and rotated. The individual chunks have patterns that can easily be matched up. The surface of Europa is so cracked that it can make it hard to work out which cracks formed first, and therefore what the sequence of events was. This may indicate that Europa is still undergoing active expansion. Let's see if we can find another example similar to Europa. Let's now examine Ganymede. Ganymede is probably one of the best examples. It is the largest and most massive of all the moons in the solar system. It is the only moon known to have a magnetic field. Similar to Europa, it is thought to be made up of equal amounts of silica rock and water. And again, it is thought that there is an ocean buried underneath an ice crust. It is speculated that this ocean may contain more water than all of Earth's oceans combined. Dark regions saturated with impact craters are thought to be the oldest. Lighter regions are cross-cut by extensive grooves and ridges similar to those that we find on Europa. Once more, the heating mechanism required for the formation of the grooves terrain on Ganymede is an unsolved problem. It is believed that it is mainly tectonic in nature. It is believed that Ganymede did undergo a slight expansion due to both phase transition in ice and thermal expansion, but this would only be an expansion of about 1 to 6%. If we examine the surface of Ganymede, what becomes immediately obvious is that the older parts seem to have spread and separated similar to those smaller areas that we saw on Europa, and also similar to our own continents. Again, here we see strong shape conformity between these chunks, and it is possible with some effort to piece these together. Here I will show you a sped up clip to demonstrate how easily this process actually is. It is important to realize that the final product still contains large tears and sinuses, similar to the reconstruction of Pangaea, and this is because I have done this process in 2 dimensions. And these sinuses should actually match up if we were to wrap them around a smaller globe. If this process was created through tectonics, then we would see areas of expansion like the mid-ocean rifts and also subduction zones with terrain elevation, and this would mean that we would see some slabs being brought closer together and some moving further away. What we see is only expansion. Similar to the Earth, we see areas where the expansion is happening much faster and may indicate areas of uprising which caused the expansion in an asymmetrical way. When we examine the pieces which have been put back together, it is immediately obvious that this landmass was much smaller than the size of the current moon. The only way that we could explain that they all fit together would be that this would either be another Pangaea with a massive continent on one side of the planet, or that it was a much smaller globe. The problem with the Pangaea concept is that this would raise serious questions about why this was much taller than the lighter material, and how it was initially formed. If Ganymede had expanded, then we would expect the original surface crust to have been fractured in this process, revealing the surface below, which would then harden over time. When we examine my reconstruction of old Ganymede, we see that the light and dark areas do seem to flow into each other. If this was an expanded crust, we would also expect to see conformity from one side to the other. And this is a little harder to do as this is a 3D projection, but by looking at the original position of the pieces, we can see that both the right side and the left side join. So what of the other moons of Jupiter? The closest moon is Io. It has the highest density of all the Jovian moons, and the lowest amount of water of any known object in the solar system. Looking at a map of the surface, we can see over 400 active volcanoes. It is considered to be an extremely geologically active moon. We can also see large mountain areas dotted across the surface. There are almost no visible crater marks on the surface, and this points to a geologically young surface. So do we see any evidence of an expansion here? There are certainly some smaller examples of surface slabs that seem to have drifted apart, and may well have been closer together originally, and there are larger slabs that seem to sit much higher than any other feature. If we examine a surface reconstruction of the elevation of Io, this maybe becomes a little bit more apparent. The evidence here is not strong, but maybe we're seeing a sliding scale. Here expansion is so violent or so often that much of the surface is rewritten before it has time to set. Maybe the large chunks and mountain regions are all that is left of the original skin. Now what of the other large moon? Callisto is the fourth moon out from Jupiter. Its surface is very cratered, indicating that it is the oldest and shows no sign of tectonic activity or volcanism. It has some very large structures with concentric rings moving outwards like ripples that are thought to be impact craters. Other than that, there is really no signs of an expansion process going on. So is there a connection between the distance from the planet to the moon that affects this process? In the next episode, we will examine the moons of Saturn to see if we see this same process going on as well. As always, be brave, be curious, the truth is waiting for us. Until next time.